Hello and welcome to another Tidy Tuesday summary. In this video we will analyze movie profits of different genres over the last 4 decades. We're going to see that horror movies sometimes have incredibly high profit margins, out-earning the production budget by a factor of 400 in some cases. The movie profits dataset did improve over the last 2 years, but still has some caveats that provide a valuable lesson we should apply to all datasets we come across. We will find the distributor with the biggest worldwide gross and see how many movies each of them made within each genre, and what the production budget distribution looks like. We will also make a graph showing that from the top 10 movies ranked by profit ratio, 5 are horror movies. Showing how the median profit ratio changed over the last 20 years is a good exercise for averaging data on an annual basis. And at the end I will show an interactive graph like this one and some fast addition and analysis, for example the correlation between US domestic and worldwide growth. As always, this summary is based on the excellent live screencast from David Robinson. There's a link in the description to the original video and channel. He's live every Tuesday 5 PM Eastern in case you're interested in the analysis of the newest Tidy Tuesday datasets. These are the functions that will be used for the analysis in this video. I hope you're interested. Let's get started. The best way to load the data is via the Tidy Tuesday R package, by simply specifying the date and extracting the movie profits object. Or you copy-paste the URL link into the read CSV function. The code lines to load the data and the relevant packages are pinned as a comment below. In the original video, David spent quite a bit of time to clean up the dataset. It was full of duplicates. For example, in the old dataset, this is how it looked for Halloween movies. There were 2 movies both repeated 5 times with different genre info or different distributors or MPAA ratings. Now, each movie comes with a unique release date and meaningful data. And whereas before, counting the distributors would give many weird number values, now the dataset is all pretty and ready to be analyzed. But there's still a caveat worth mentioning. The dataset is not comprehensive. First, because it was released in 2018 and won't have any recent movies included, and secondly, there are also huge gaps within the genres. For example, when I look at the top 30 movies from a worldwide gross perspective, only 3 movies from that list are actually included in the dataset. The lesson to learn here is that whenever we analyze a dataset, we have to make sure how it was compiled and which gaps it might have. Otherwise, we might make mistakes when coming up with rankings and absolute statements of minimum and maximum values. Nonetheless, if we want to find the top 10 best performing movies of each genre within this dataset, there are several ways to do it. The easiest way is to use the view function. Click on the arrows in the worldwide gross column to sort by decreasing values, and then use the search field to enter the genre. It will keep the sorting mechanism in place even when we change it to another genre. Another way to do it is via the select, arrange and filter functions. Here we specify relevant column names like release date, movie title, worldwide gross and genre, then arrange by descending worldwide gross again and specify the genre to filter by. If your dataset is a tuple, it will only show the top 10 results. If it is a data frame, you could add the head function and specify n equals 10. Now you can repeat this code and simply change the genre within the filter function to get all the different top 10 lists. A more automated way would involve the summarize and left join function. Summarize allows us to apply a function to a certain group. In this case, the group will be genre and the function is head, which gives us the top n entries. To get the top 10 movies, we first have to arrange by descending worldwide gross and group by genre. To keep the movie title, we have to use the head function a second time, but now not to get the top 10 worldwide gross numbers, but the top 10 movie names. As you can see, this is a bit tedious if we want to keep the information of other variables like distributor, release date, etc. So here the left join function comes in handy, where we can combine the 50-row summary results with the original dataset. Based on the movie name, it will combine all columns from movie profits with our top 10 by genre results table. Because the results table already had genre as a column name, the left join function will create an X and a Y version and duplicate the data. It will also show the worldwide gross again, which is identical to the top 10 gross column. As I said, these top 10 lists aren't that meaningful given the lack of comprehensiveness. However, I only realized this after I made these slides to show the top 5 movies from each genre. So these are the top 5 best-selling movies by genre from this dataset. You can see the worldwide gross is roughly double the US domestic gross. And for horror movies, I created a top 10 list. Because we are going to plot changes over time, it makes sense to clean up the release date column. At the beginning it comes as a character vector where month, day and year are separated by forward slashes. This format we can specify in the parseDateTime function within the order argument. The capital Y is used because the year comes with 4 digits. This function also creates unnecessary time information that we can get rid of by using the asDate function as well. Let's look at the distributors of the 3401 movies from this dataset. With the count function and the sort argument set to true, we get a table showing the top 10 distributors and another 192 not shown. Warner Brothers, Sony Pictures and Universal all have over 300 movies included in this dataset. On the right hand side, I added a scroll down of the viewer to show that on position 15 we get 48 NAs reported as well. This is different from the table function that you might be more familiar with. To not miss the NAs with the table function, you would have to specify exclude equals null. Dealing with so many different distributors will make plotting the results really difficult. Here, the fctlump function comes in handy. The n argument specifies the number of the most common distributors we want to keep. This will turn a character vector into a factor where all other distributors get overwritten with other. NAs are still kept as NAs. Now the most common distributor in air quotes is other. Here's a slideshow of the top 10 distributors and some selected movies. Some of these distributors you might not have heard of before or associated with some of these iconic movies. New Line went quite a long way from Freddy Krueger to Frodo Baggins. Let's arrange the distributors by the median worldwide gross of their movies. For this, we have to use the FCT reorder function as well, and we filter out the few NAs. It is always a good idea to apply a log10 transformation to money values, as there will be movies that made only $100,000, whereas others made 10 million, 100 million or even $1 billion worldwide. Notice that all the other distributors lumped together show many outliers in the lower grossing area, around and below 10k, something that almost never happens to the bigger production houses. Another thing we can ask about the distributors is whether they have any genre preferences. To generate this graph we need the following R code, which is a bit complicated, so let's get through this step by step. The fctlump is clear by now, but the add count might be new. It generates an n column that adds the total n per genre to each movie row at the end. This will be the basis for the sorting of genres within the FCT reorder function. Next we do another count for distributors and genre combined, which will give the n movies per genre for each distributor, which will be the basis for the ggplot function, where we use the movie count n on the y-axis and genre on the x-axis. With chord flip we can make the genre more readable. We did use fill equals genre within the ggplot to color the bars, but because we have the genre spelled out on the axis we won't need a legend and can set show legend equals false within the geom_call function. The facet wrap simply reproduces this bar chart for each distributor. Now, because other lumped so many less common distributors together, it is a bit hard to see the pattern for the top 8 distributors. What we can do within facet wrap is to free the y-axis, and remember the y-axis is on the bottom due to the chord flip. Now it has different ranges, sometimes going from 0 to 40 for MGM, but from 0 to 100 for Universal, and for others even up to 600. Drama seems to be the preferred genre, Lionsgate going for horror quite a bit. The one horror movie for Walt Disney is actually a mistake, because Walt Disney did not produce or distribute the movie Stay Alive, where a video game becomes all too real for the players. Lastly, with the following code we could visualize not the numbers of movies per genre for each of the top distributors, but the box plot of worldwide gross, and here it is advised to not free the axis to have better comparability. If we want to analyze the profitability of a movie, we first have to talk about the production cost. We can plot the production budget with ggplot and use the geom histogram function for visualization. When we are dealing with monetary variables, it is often advised to add the scalexlog10 function, where we can also specify the labels equals $format function as an argument. We see that most movies fall in the range of $10 to $50 million, some are below 1 million, some above 100 million, so it made sense to use a log scale. Next we can add a second dimension, namely the genre. Within Mutate, we apply the FCT reorder to sort the genre from highest to lowest production budget, puts the genre on the x-axis and the production budget on the y-axis, use chord flip to make the genre more readable, and use geom boxplot to preserve some of the distribution information. Log 10 scale will be applied again. The median production budget ranges from 50 million for adventure to 10.75 million for horror, action movies being second with 44 million on average. Here I show the production budget for distributors to check if some spend a lot more than others. Without the FCT lump or FCT reorder function, this information would be hard to digest, but by lumping everything past the top 10 distributors together, filtering out the NAs, and sorting by production budget, we see that Warner Bros. Spent the most, but the next 5, from 20th Century Fox over Walt Disney and Universal to Sony Picture and Paramount, are very similar. There's a break then for New Line and MGM, Miramax and Lionsgate. Those all have their blockbusters, but on average spend a lot less, as do the others that are lumped together. Sometimes box plots are not the easiest to read, especially when on a log scale. That's why I show the summarized results along with the sample size of movies as well. Warner Brothers 40 million median is 4 times as much as the average of the 1073 movies from the other not top 10 distributors. There's a way to go into even more details with the facet wrap function. Here we can combine the 2 graphs we had before, where we first split by genre and then had box plots for the top 10 distributors. Now I lumped the 8 plus others together, giving us a nice 3x3 matrix, and within each distributor window we get the production budget as box plots for 5 different genres. Now we can calculate and visualize the profits from each movie by dividing the worldwide box office gross by the production budget to get a profit ratio, and with a simple subtraction we would get the net profit. Geom histogram on a log scale gives a familiar picture. Most movies are above the 1 ratio, meaning they made a profit. When you are at 1E plus 1, you made 10 times your production budget back. When you are at 1E minus 1, you only got 10% back of what you spent to make the movie. Again, we add the genre dimension and use box plots to visualize the spread of the distributions. To make the ratio scale more readable, we can transform the labels by pasting the ratio value together with an X to represent the times or fold factor of the ratio. And with breaks, we can specify where exactly the labels should appear. I choose the brackets 1%, 10%, which represent losses, 1x, which is break even, and then 10x and 100x profit ratios. All genre medians are between 1.5 for drama and 2.6 for horror. Adventure and action had the highest production cost, as you might remember, so these have to earn a lot to generate a profit. For horror, it's a bit easier given the lower production budget. Group by and summarize gives us these median ratios, and with arrange and FCT reorder and geom call we can visualize them. So on average you make around 1.5 to 2.5 times your money back, but here are some exceptions to these rules. The 2 movies that had the highest profit ratios are Paranormal Activities and The Blair Witch Project, which only took around $500,000 to be produced but made 194 millions and 248 millions back, which is a 432x and 414x profit ratio. That is kind of the magic formula, not being overly expensive but somehow hitting a nerve, going viral and then making a lot of money. I remember watching Blair Witch in the theater when it came out in 1998, and the movie wasn't that scary because not much is shown and it mostly happens in your head, but my way back home from the bus stop was extremely scary. Being all alone in the dark is not advisable after such a movie. Here are the other 8 of the top 10. As you can see, 3 more of them are horror movies. Halloween, Friday the 13th and The Devil Inside all made 100 to 200x their money back. Bambi and Rocky were also big successes, as were American Graffiti, Napoleon Dynamite and Gone with the Wind. There are 3 more bar charts I want to show. Function-wise, there's nothing new to them, but there is a basic trick with which you can combine the movie name and the release date. Within Mutate, we can use paste 0 to add the release date either in parentheses or with \n as a line break on a new line. Fill within the context of geom call will color the bars with the genre information. And if you want to label the legend, you can do that in labs, giving the fill argument the genre name. No action movies made it into the top 50 in profit ratios. For this graph, I put the release date into parentheses and filtered only for horror movies, used a fixed color, namely orange, to be used as fill, and then it is helpful to specify within geom call that show legend equals false, otherwise you get an orange box saying orange, which is pretty ugly and useless. If we use fill for distributors, we get the bar coloring matching the distributor, and here we see 4 blue bars showing Paramount distributed 4 out of the 11 horror movies with the best profit ratios. And you see see that Universal joined the trend with Split and Get Out in 2017, which were both huge successes and made around 50x their investment back. This is the plot from the thumbnail showing the median profit ratio of each genre for every year since 2000. And as most genres wiggle around a 2x profit, horror movies skyrocketed to 6x and 8x after 2012. To produce this graph, we have to do some data manipulations first. We want to summarize the median profit ratio after using the group by function for genre and year. As you can see in the results table, because we filtered for the years greater or equal than 2000, we get a median profit ratio for action movies from 2000 till 2018. It is always good to use the n function within summarize to have an idea about how many movies per year and genre the summary statistic, in this case the median profit ratio, is based on. That is the main reason for why I filtered for 2000 and above, as for earlier years the sample size is rather slim. A simple table of genre and decade gives us the sample sizes. Plotting this is easy with a geom_line function, however the coloring for genre can now no longer be done with fill, but by using color within ggplot. If you like this video and want to see more in the future, feel free to leave a like and subscribe to my channel. Or leave a comment about your favorite horror movie of all times. For data exploration, it is always nice to have an interactive graph, and with the ggplot package these are really easy to produce. All we have to do is to store the plot in an object like g and then call this object with the ggplotly function. This allows you to zoom in and out of the graph, and with hovering over the points we get extra information like the movie title and profit ratios. For example, in comedy, one of the worst performing movies was Police Academy 7 that only made 1% of the production budget back. Home Alone and Napoleon Dynamite made 31 to 115 times the investment back. In horror movies, Blair Witch Project, Saw and Paranormal Activity did really well. I was also interested in the correlation between US domestic and worldwide growth. Maybe there's a genre that only performs really well in the US but not outside. But looking at the results where I used core test within summarize and then extracted the estimate, they all show a really strong correlation overall. When I apply a log10 transformation, the action movies fall off a bit. Now the question would be if this decrease of the correlation coefficient is caused because action movies perform better outside or within the US. You can visualize the correlation with the following code. Then I was interested in the MPAA ratings, which Wikipedia describes like this. The dataset contains this information, as you can see here, with the count function. With the table function, we see that no horror movie is for the general audience and most often rated R. There's a clear picture when we look into the profit ratio or net profit a movie makes depending on the MPAA rating. This makes sense because when you restrict your audience, it reduces the customer base and diminishes the profit the once produced movie can make. And lastly, one can easily get into even more details by splitting the profit ratios and net profits by genre and MPAA rating. I haven't found a good way to visualize these results, but I think there's definitely some insights here to point out.